Hello guys, today we are here with yet another topic and we are going to crack all these difficult and confusing topics along with the examples of the PYQs, okay? This will help you practice. So we are going to start with the very first PYQ here. It is an INICT PYQ. It is going to so the very first PYQ that we have chosen is the easiest of all. So it is saying that the inward pressure in the provided circuit is 100 mmHg while the outward pressure is 10. Now the resistance given is 5. Now we have to tell the flow rate. So we know from physics that delta P is equals to I and R. Here I is not your current but it is the flow. So we can use the same formula for both of them. As we know the resistance are connected in parallel, तो वैसे तो resistance का formula is 1 by R1 plus 1 by R2 and so on, but we know the simple trick is कि if there are 5 resistances arranged in parallel and all of them are measuring 5, then the resistance equivalent would be 1. Okay, so taking your resistance as 1 and delta P as 100 minus 10 is equals to flow into 1. So your flow would be 90 here, and this is your answer. Now moving on to the next question. This is a graph, ejection fraction graph, which most of us find difficult. So what happens is, what we have to tell here is the ejection fraction. So now, as we know, this is the there is a trick for solving this question, but first we have to start with the concept. So we know that this is the isovolumetric relaxation from A to B. No, sorry, I'm very sorry. It is the isovolumetric contraction from A to B, and then it is the isovolumetric relaxation just opposite to that. And here it is the ventricular systole from B to C. So what happens is, since this is the case, so that is why this 130 is the end diastolic volume and 50 is the end systolic volume. So we know that 130 is the end diastolic volume, 50 is the end systolic volume. So then the flow volume would be 130 minus 50, which is 80. Okay. And here we have to tell the ejection fraction. So ejection fraction is equals to stroke volume, that is the flow volume, upon end diastolic volume. So here we can put 80 as the flow volume and 130 as end diastolic volume. So we get 0.61 something as the fraction. Converting it into percentage, 60 would be your most appropriate answer here. Moving on to the next question. From the next question, you have to tell the flow in vessel 1 as compared to vessel 2. So vessel 1 में क्या दिया हुआ है? That the length is 2 times and the diameter is also 2 times. So as we know from Poiseuille's law, we know that resistance is directly proportional to length and inversely proportional to radius की power 4. Okay, it is inversely proportional to radius to the power 4. So now what we are going to do here is कि figure 1 में the length is what 2 times and the radius and this radius is 2 times. तो 2 times radius का 4 हो जाएगा what 16 times. Cancelling it, it would be 8 times. Okay, so this would be 8 times. So then we know that this is the resistance, which is 1 by 8. तो flow तो उल्टा होगा, तो then the flow would be 8 times. Because radius is the major contributing factor more than the length, so 8 would be the answer here. Now this is yet another question which all of us used to find very difficult. I also used to find it very difficult. Now here what it is saying that according, if we go according to the concept, then the concept is कि यहाँ पे from A to B is it is isovolumetric contraction. तो isovolumetric because we can see in the graph itself कि यहाँ पे volume constant है when we go from A to B because it is on the y axis or x नहीं because it is on the x axis और y axis पे यहाँ पे प्रेशर बढ़ रहा है. ठीक है, कॉन्ट्रैक्ट जब कोई भी एरिया करेगा देन द प्रेशर इज ओनली गोइंग टू इंक्रीज ना. और सिंस वॉल्यूम यहाँ पे कांस्टेंट है फ्रॉम गोइंग टू फ्रॉम ए टू बी, तो ये आइसोवॉल्यूमेट्रिक कॉन्ट्रैक्शन हो गया कि कॉन्ट्रैक्शन इटसेल्फ मीन्स कि वहाँ पे प्रेशर बढ़ेगा. ठीक है, सो दिस इज़ योर आइसोवॉल्यूमेट्रिक कॉन्ट्रैक्शन, दिस इज़ योर ventricular systole, and just opposite to this is your isovolumetric relaxation. ठीक है, now we have another trick for this. Another trick for this is कि your systole starts with this. We have to start from point A and it is cocomam. Okay, there is a mnemonic for this, that cocomam. We start with cocomam, which is your mnemonic. Okay, yes, so here C is for closure, O is for opening, M is for mitral valve, and A is for aortic valve. Okay, so this starting from the point A, this is coco. So this is closure of mitral valve, this is opening of aortic valve, this is closure of aortic valve. And this is closure of mitral valve. No, this is opening of mitral valve. So then what we can see here is कि यहाँ से लेके यहाँ तक it is the isovolumetric contraction. और आइसोवॉल्यूमेट्रिक कॉन्ट्रैक्शन में द लेफ्ट वेंट्रिकुलर प्रेशर इज इक्विवेलेंट टू द डायस्टोलिक ब्लड प्रेशर. ओके, सो इट वुड बी पॉइंट बी. Here we can come to our answer, which is point B. Okay, now just revisiting to what we learn here कि यहाँ से our systole starts. ठीक है, and the mnemonic for this is cocomam. This is isovolumetric contraction, this is ventricular systole, and this is isovolumetric relaxation. ठीक है, this is how you go about this question. And isovolumetric contraction is where left ventricular pressure is equals to the diastolic blood pressure in the aorta. Left ventricular pressure is equals to diastolic blood pressure in aorta. Okay, so here we have completed all the 4 questions that I have selected for you in physiology, because these are the areas which we find very confusing and challenging at the same time. So here I am going to post every day important INICT PYQs, since INICT is the next exam that we have in the near future. So stay tuned and do subscribe if you want such content, and share our content and press the bell icon so that you get notified of all my upcoming videos. Thank you so much. Have a nice day. And have a nice day. Bye.